Okay, another sample problem on projectile motion. A golfer is hitting a golf ball. Here he is here. There's his beautiful club, beautiful diagram. It's traveling at 32.6 meters per second, but at an angle of 65 degrees above the horizontal. The ball lands at a height of 6.3 meters. Find the time that the ball is in the air, bink, and how far it travels. So this question is immediately different from the other one because the other one had no y velocity to start. This guy has a y velocity. As a matter of fact, he's got some x velocity, he's got a little x, and he's got some y in this question. So my suggestion to you is always, 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 when you've got a question that where the initial velocity is on an angle somewhere, so it has some x and some y, you just find out what it is. So over here I've drawn a little triangle, 32.6 meters per second, there it is there, angle of 65, and I just want to find this, the y part and the x part. The x part is adjacent to the angle, so I used cos of 65, and I got 13.8. The y is opposite that angle, so I used sine of 65, and I got 29.6. So if you try and decide what am I going to work in, well, all I have in the x is vx. I want dx. I don't know time. I'm not getting anywhere in the x. But in the y, I've got the initial y velocity over here. I've got a dy. I've got the acceleration is minus 9.8. So I started here in the y, and I use this equation right here. dy equals vit plus 1/2 at squared, and I started plugging in. I know the height that it's going to be at is 6.3. Its initial velocity is 29.6, found over here, times t minus 1/2 times 9.8 t squared. When you look at this guy here, I've got a number, a t term, and a t squared term. That's a quadratic. And in an ugly situation like this, the numbers are definitely not nice. I can't just factor that easily. I can use the quadratic equation. Negative b plus or minus the square root b squared minus 4ac all over 2a. And I guess I'll just write that over here. It's negative b plus or minus the square root b squared minus 4ac all over 2a. Here's the quadratic equation. And so what I did is I used it. Now I'll give you a bit of advice. If you're at home doing problems, you should practice it, using it once or twice. But online you can find all sorts of websites where you just have to plug in the three values, A, B, and C, and it'll tell you what the roots are, the solutions. Now when I do this, I get two answers, 0.22 seconds or 5.8 seconds, and at first I might be upset about this, because I was hoping for one of them to be negative, because time cannot be negative. And that answer would be crap. I would discard it immediately, and I know what my answer is. But both of these answers are positive. But let's just look for a second. I'm just going to cruise up here. When is the golf ball at a height of 6.3 meters? Here. But look, also here. It hits 6.3 on the way up and on the way down. So when I look at these two answers, it hits this guy on the way up, and it's this one on the way down. So this is the time that I'm interested in, but I can make sense of my answer here at least by thinking about the question. So my time is 5.8 seconds, and my velocity is 13.8 times 5.8. And just so we remember what we're doing, or where I got this, 13.8 and 5.8. I got the 13.8 from that original diagram right here, where I figured out the x velocity, which which will never change during the course of this thing, the flight of this projectile. And then I can work this out to see how far it goes, and it goes about 80 meters. Bingo. So again, taking a look, anytime you're given a question where something's traveling on an angle, first step, always break it up into its x part and its y part, and then decide where you're going to move to now. Here we started in the y, used a quadratic equation, got time, took it to the x, found dx. Common recipe for how to solve these